Welcome back to COSC 2325. For this video, you want to go into chapter 4 module and open this example, chapter 4, example 1.asm. Take a moment to pause and open and run it. Make sure that it runs. You've said everything that needs to be said. And I have several examples to cover different topics that are being covered in this chapter. So the first thing that we're going to look at is the type, length of, and size of operators. So these operators are going to do some things for us that we had to calculate in chapter 3. So the type operator returns the size in bytes of an operand or of each element in an array. So for type, you can put it in front of like type byte array. And what that will give you is 1. It's going to tell you that this array, each element in the array is 1 byte. And we'll use that one later. What I'm going to use in this example here is length of and size of. So in chapter 3, we had to calculate the length and the size of an array. And the way that we did that was to get the length of the array, we used the $ minus the name of the array. And we had to do it right, like we had to put this right after we defined the array. So it had to be like this. Let's take this out. It had to be like that. So right after you define the array, we had to call this because the $, what that does is it gives us the current location, the current address of where the current instruction is, and then it subtracts the address of where the first element lives. So it had to be right here. Well, now we have the ability to use this operator called length of. And what length of does is just tells us how many elements are in the array. It's super easy. And it's just like when you use the length function in Java or C++. And then the other one that it gives us, so here the length of this array is going to be 4. This is a word array. The length of this word array is also 4 because there's 4 elements in the array. Now for this array, we used to have to divide by 2. We used to have to say $ minus word array divided by 2 because word arrays are 2 bytes for each element. So each of these elements is 2 bytes. And so it would give us the address minus word array would give us, let's say that this started at, let's say that this array started at 0. So this would be, this element would be 0, this would be 2, this would be 4. So 0, 2, 4, 6. Because we're incrementing by 2 bytes. So the next instruction would start at 7. So it would do 7 minus 6. Excuse me. 7 minus 0. Not 7, it's 6. Okay, so let me try again. 0, 2, 4, 6. So we'll do 6 minus 0 because 0 is the start of the array. And oh, okay, let me just put this up here. So this would be 0. This would be 2. This would be 2 more bytes would be 4. So this 30 would start at 4. 4 plus 2 would be 6. So this 40 would start at 6. And because that 40 is 2 bytes, it takes a whole 2 bytes. So the next instruction actually starts at 8. So next instruction is at 8. Let's say address 0008 or something like that. So then it takes that 8 minus where the array begins, which is 0, and divides it by 2. So 8 divided by 2 is 4. There we go. And the length of our array is 4. But here we can just call length of, and we don't have to call it directly after we define the word array. We can call this anywhere in our code, and it's going to give us 4. So let me put that there so I don't get an error. And then the size of operator returns the number of bytes used by the array. So if we look at the word array, which is this one right here, we're using, it's going to count how many total bytes we have. So each of these is 2, there's 4 elements. So we have 8 bytes that we're using. 8 bytes right here. And then in this next line, we're moving 11 binary into a byte. So var1 is a byte, and this is 11 binary. So var1 contains, and we're going to use that for, we're going to look at something with this variable. So first of all, let's take a look at our first example. So we're going to see what's in these variables that we created. So length byte array is this one. That's going to give us 4. Length word array is going to give us also 4 because there's 4 elements. Size word array is going to give us 8. And then wait to do that one, because I want to show you what that one's all about. So I'm going to take my cursor and I'm going to put a breakpoint at line 26. And you can do this with me and run it. And I want you to look at the EAX, EBX, and the ECX registers. So I haven't stepped through it yet, but once I step through it, EAX contains 4, so there's 4 elements in the byte array. There's 4 elements in the word array. And then, oops, let's go back to the top here. The size of the word array. Remember, you take the 4 elements. So there's 4 elements. Each one is 2 bytes because it's word. So 4 times 2 is 8, and ECX contains 8. Let's take a look at what's happening here. So I wanted to do this move CX to show you the move CX statement using it with the byte array. So EAX, we know it's 32 bits. Our byte array is just 1 byte. So each one of these is 1 byte. So if I want to assign the first element to EAX, the only way I can do that is by using the move CX instruction. So right now EAX contains a 4. Remember the byte array, the first element contains a 10. Let's step through that. So now EAX contains a 10 also. And remember that I put these in hex. So I just want to show you, where's it at? Right here. So I put H so that you could actually see 10 hex, 20 hex, 30 hex. Instead of seeing 10 decimal, you're seeing 10 hex. So that's why you see a 10 here in the EAX register. And again, if I want to put the next element, I just put a bracket. And because this is a byte array, I'm going to add 1. So now, at first I have to stop it because I made a change. I'm going to run it again and debug. I got this at the breakpoint. I'm going to step through the line and I'm going to have 20 hex now, which is the second element in the array. This one right here. No, not that one. Sorry. This one right here. Okay, so let's look at the next example. So that's using those operators. This next example and the ones following, we're going to look at the different flags that get set. And we're going to be using these flags when we look at conditional statements, like, is this greater than that, or less than that, or less than or equal to. But right now, we want to look and see how they get set, how they function. So my suggestion is that you play around with these and really get a good idea of how the flags are getting set. So in this video, we're going to look at the control flag and the signed flag, the 0 flag, and those are the only ones that we'll be looking at. Okay, so the first one here is we're looking at it, the sign, the carry flag. So the carry flag is set anytime that you do arithmetic with unsigned integers. They have to be unsigned for us to look at the carry flag. So if you're using signed integers, don't even look at the carry flag. Like whatever's there, you're not gonna pay attention to it, okay? But we're just gonna pay attention to the carry flag if we have unsigned integers. And if we have unsigned integer and there's an overflow, then the carry flag is going to get set. It's going to get set to a 1. So let's take a look at what we're doing here. So in this example, we're moving 1 into ECX. So let's see what that looks like. So if I set a breakpoint, so we can see our registers. Okay, so I'm going to move through this 1 into ECX. So here's ECX and I have a 1. Now what I'm going to do, now remember this is 1 hex. I'm going to subtract 2 from here. So I'm taking 2 away from 1. When you cannot take 2 away from 1, that means that you have to borrow. So when you try to take 2 away from this 1, it tries to borrow from the number to the left, and it can't borrow. It has to go all the way over here. So when you are borrowing, that's going to make that carry flag get set. So let's take a look and see how it gets set. So take the breakpoint off, and I'm going to subtract 2 from ECX. I also want you to look at a sign flag. The sign flag tells me if I just, by what I did, if I did like an addition or subtraction, well, it won't happen with the addition, but if I do a subtraction or I decrease my number, if I decrease into negative, it sets the sign flag to negative so that I know that I've now reached a negative number. So in Visual Studio, PL is going to be your sign flag. So in your book, it's going to say, I think sign flag is going to say SF maybe, or N for negative, NF. And then CF is going to be your carry, which actually it's CY here in, so let me change that. And it'll be correct on your copy. So CY is going to be our carry flag. Shouldn't put CY. So this will be CY. If you're looking at it in Visual Studio, you CY, CF in your book. Okay, so we'll put a breakpoint there and run it again. And now when I move through the subtract, so I want you to look at the flags, right? ECX is 1. When any of these flags turn red, it means that whatever we did here affected the flag, okay? So let's move through it. All right, so by subtracting that 2, so 2 is much bigger than 1. It means that we have to borrow. So the carry, it got set to a 1. And then this here is the sign flag. It also got set to a 1. Now, we're not looking at this flag right now because we're not going to be using it, the auxiliary carry flag. So don't worry about this flag. We are going to be looking at the parity flag. I think in chapter 7 a lot. And when it turns, right now it did not turn red, but when it gets set, 1 means that it's set, okay? Now, if it's black like this, it means maybe it got set prior to this, but this instruction did not set PE, parity, to 1. This instruction only set sign. It set the 0 flag, and it set the, it didn't set it, sorry. The 0 flag got cleared, and it said this flag and this flag. So 1 means set, 0 means cleared. So subtracting 2 set these 2 flags. So you might want to try different numbers, like let's change this to a 1 and see what happens. So we're taking 1 away from 1. And let's go ahead and set our breakpoint. So you're going to get this error if you forget to stop. Like if you make a change like I just did and you don't stop the debug, then it gives you that error. It's not, okay. It's fine. So let's look at our registers. So here we've got ECX set to 1, and then now we're going to subtract 1 from ECX. So notice that ECX is 0 because we subtracted 1 from ECX right here. So the 0 flag was set already, so it did not need to be reset. That's why it didn't turn red. So it was already a 1. But then this one got cleared, and earlier this one was a 1, and that one got cleared also because it's not a signed number and we didn't carry. Okay, so I'm going to put this back to a 2. I'm going to go ahead and comment these out so we can look in the next example. So in this next example, instead of subtracting, we're just using a new instruction to decrease you can decrease a variable or a register with DEC. So here we're moving 2 to ECX. We're going to decrease ECX by 1, decrease by 1, decrease by 1. So this first one, it decreases the number. So now 2 minus 1 is 1. Then we decrease by 1 again. So 1 minus 1 is 0. So the 0 flag's going to get set, which remember the 0 flag is so weird. It's PL. Took me forever to find. So PL gets set. PL will be 1. And then ECX will equal to 0, right? And then here we subtract 1 from ECX, and ECX will equal a -1. So our sign flag, please confused. 0 flag is ZR equals 1. Sign flag is PL equals 1. There we go. So 0 flag is ZR. That one makes sense. Sign flag is the one that is PL. So we'll put a breakpoint here in the first decrease decrement statement. Okay, so we have 2 in ECX. We're going to take 1 away. Okay, remember I'm doing step into, which is F11. So I step into it, and now we subtract 1 from 2, so we're at 1. So everything's good. It looks like 0 flag got cleared. It probably had a 1 before, and this one had a 1 before. So those got clear. 0 means clear. And then we're going to step again into it. So now ECX becomes 0. And the 0 flag gets set to 1, which means that we have a 0. And then this is parity, and we haven't talked about parity, but we'll talk about parity as soon as we start using it. But there's no need to discuss it now because we're not going to be using it. So we're going to do it one more time. And then we subtract 1 from 0, which gives us all F. So -1, by the way, in hex is all Fs. So if you see all Fs, you know that it's -1. So PL got set to 1. 0 got cleared because it's no longer 0. And the auxiliary carry flag got set. And we're not using this one either. We're actually not ever using that one, so we don't have to worry about that one. But we'll worry about, for right now, 0 flag and PL, which is a sign flag. So we're going to stop, and you can just go through and put different numbers on here just to see what happens to each one of these, okay? It's just kind of playing with it. Oh yeah, the other flag that we really want to look at is the overflow flag. So remember I said the carry flag, you're going to pay attention to it when you're dealing with unsigned integers. So if you're adding, subtracting unsigned integers, then the carry flag is what you pay attention to. If you're dealing with signed integers, then you're going to look at the overflow flag. So the overflow flag is set when the result of a signed arithmetic operation overflows or underflows the destination operand. So remember that we have ranges that a byte and a word and a double word can take up. So the range of a signed byte is -128 to +127. So if you go if you try to put into AL, remember AL is it's just a byte size register, AL. If you try to put into AL 128, you're going over the range. So you're going to overflow. And if you try to put a negative 127, so out of the range on the negative end, then you're going to underflow. So it's going to set the overflow flag, whether I go to something less than negative 128 or something greater than 127. So if I go, let me open a new window. So if I search in my search engine, if I type range of a signed byte right here, range of a signed byte, it gives me the range. Range of an unsigned byte. Zero to 255. So again, if I if I go out outside these ranges, and it's unsigned, don't look at the overflow because this is an unsigned number. We're just looking at signed numbers. So let's say that we want to look at the range of a signed word, and I'm going to put assembly. Let's see. Range of assigned of bytes. Yeah, here we go. Okay, so for 2 bytes, if it's signed, this is your range right here, negative 32,768. So anything less than this or greater than positive 32,767 is also going to set that overflow flag. So we can try these numbers also. So right here, in this example, we're moving negative 128 into AL, and then we're adding a negative 1. So it's going to get to negative 127 with these two statements and set the overflow flag. So right now, AL, we haven't moved through AL, but remember that AL is going to be this byte right here. So we step through it. So see how this changed to 80 right there. And then let's see. Let's look at the flags. So we're going to be looking at this flag right here, the OV flag. Right now is 0. Okay, so step through it. And OV got set to 1. Now, don't worry about this carry flag. We're not even paying attention to this carry flag. We're only paying attention to the overflow flag. Okay. 0 just got cleared and this one got cleared also. The sign flag. Okay, let's stop and let's go ahead and change this to, we can do, or if you want to try it at home, that way I don't take up too much time, try assigning positive or negative. Let's do negative. You can do it, you can do the positive 32,768 if you assign it to a word variable. So here, 32,767. 32767. So right here in the data section, you could say 32767 R2 signed word 276. So if we assign that, and remember you can put a plus sign there. So just like we assigned this one, put a negative. Now it knows that it's definitely assigned word. So it would then, if we added 1 to this, it would change your overflow flag and set it. Okay. So the last one we're going to look at is this one. So what I wanted to show you is, in this example, this is how you fill up all 32 bits in the ECX register, right? So there's 32 ones right here. Each of these ones is 1 bit. If I add 1 to this, so 1 plus 1 will be 0 and it'll carry a 1, and then 0 carry a 1, and 0 carry 1. It's going to just go 0, 0, 0, 0, and carry a 1. That 1 that gets carried out is the 1 that gets put into the carry flag. So that is what we mean by carrying. It means that we're carrying that 1 into the carry flag. And if we don't carry a 1, then that carry flag gets set to 0. So let's look at this example. First of all, I want you to look at the ECX register. So right now it has that value. And then when I step through it, it has 1, 1, 1, 1, 1, all that in hex. So this is binary. So all these ones in hex looks like this value. So again, let's just count these. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Oh, looks like I'm missing 1. Again, should be breakpoint. Okay, again, we're looking at ECX. I'm gonna step through it. There we go. So all my 1s, I have all Fs, because remember that in hex, FFFF is -1, and 1, 1, all these filled in, 32 bits, or all 1s, is also a negative. It's going to be -1. So then we're going to add 1 to -1, and it's going to set it to 0. It's going to set my ECX to 0. And remember that it's just doing 1 plus 0, 1 plus 1. So it sets all these to 0, and it carries that last 1. So 0 was already a 1, and then the carry flag got set to a 1. This is really what we want to look at, is that carry flag getting set to a 1. So we're going to stop this. So let's say that I wanted to do the same thing with instead of ECX, I'll do AH. Actually, let's do AL first. So AL. So AL is 2, 3, 4, 5, 6, 7, 8. It's gonna be 8 bits. this here. And let's look at the AL register. I'm going to zero out the ECX register, just it makes life easier to see things. So ECX, oh, sorry, this is the EAX register. Okay, so EAX is all zeros. And now I'm going to step through it. And now we see FF in EAX. I just want you to know how to fill up, like how to fill up each different register. So you can see the values and you can play with it. So play around with these flags, setting them and seeing what flags get set, okay? In the next video, we're gonna look at here. We've looked at indirect addressing, but we're gonna do it with looking at loops. So we're gonna do the jump and loop instructions and take a look at them and see how we can go through an array and add all the values in the array and just using a loop with assembly. So that will be our last section. Okay, please send me an email if you have any questions and make sure that you go through and look at those flags and how they get set. Thank you.